can you like type out the question in chat, or you can like say it out loud?
Okay, just the second section of our homework where you just need to write out the divisibility rules of
Oh, okay, okay.
numbers.
Yeah. Did you get the slides that I sent out? What,
Yeah.
sorry, Eric sent out? Yes?
Yes.
Yes, okay. Then you can go back to the notes and review the visibility rules and just write it out again. I just want you to write it out again.
Okay, got it.
Okay, cool.
I wonder if my friends have Zoom. Like, I have a Zoom account, but I'm just playing as a guest currently, and
okay.
I want to have like Zoom meetings with my friends, but like I don't know how to start it. But yeah.
Okay. Okay. Cool.
what?
Edward, can you send me your email again? It seems like I didn't record it last time. Is that fine?
Sure.
Thank you. Okay. Let me see. Oh, should probably check. Okay. And for people who are arriving right now, here's the warm-up. So you can get started on it. And then if you want, you can send Eric or me the answers so we can verify it. We're just going to move on in about 5 minutes. Okay. And we'll go straight to announcements.
What kind of like Outlook, Gmail, Hotmail thing? Where do you like send the slides to?
It doesn't matter. I send emails out with the slides and homework.
I know that you send it, like, but I just don't know where you send it on. Like, you can send it to Outlook.
It's email, so it should arrive in Outlook. It should arrive in Gmail. But I think Gmail is easier if you have that.
Gmail is a lot easier, but there's Google Meet on it.
Okay.
Gmail has Google Meet, and it's basically Zoom meetings, but it's just a lot.
Yeah. If you have a Gmail, then you can give me that, and then I can send you the homework on there.
I have a Gmail, but I don't use it too much. I just use it to like contact my other friends. I have like more friends. One friend talks to me on Skype. One friend talks to me on Google Meet. One friend talks to me on.
Oh, you can't see the screen. Wait, sorry. Is this better? I kind of.
Yeah, I can see it now.
Okay, cool. Yeah, sorry.
Well, I only use Google Meet to like be with talk with my friends. It's I don't really care about a Google account.
Okay. Okay. Well, I'll try again. If you don't receive it, then you can email me at. Let me type this out for you.
Okay.
My email at Kenzo.
Okay, I'm kind of stuck in full screen mode. I don't know how. Exit full screen mode.
Yep. So here's my email. You can email me on that email.
kentoturtle@gmail.com.
Yep.
Okay, I'll try to send it to you in Gmail, possibly.
Okay. Like if you don't see anything after today, you can email me using that email, and then I'll try and respond back to you as soon as possible. Okay.
Anyways, I kind of have so many flags in my Outlook system. Your password and email is this. Get reminded future self.
Okay. Okay.
I like doing that. It's just kind of fun, and it's also pretty efficient.
That's cool. Okay. Let me see what time is it.
So are we gonna? Okay, I'm just gonna send you the answers.
Yeah, sure. That's fine. We can send Eric the answers, as always. Sorry, that's my dog. You can hear.
It sounds like she's screaming. It's like,
hello. It's my dog, sorry.
Why does it sound so much like a bird that's trying to say something?
Mm-hmm. Okay, you guys have a few more minutes and then we'll go straight on to announcements.
Mr. Kyle?
Yeah.
Like the only multiple, well, I only see 2 answers for the number 1.
Yeah, just give me one. There's 2 answers for number 1. You can just give me one.
But I have 2.
You can give me one, or you can give me both.
Then why does it say? Oh, okay. Give me a 3-digit number. I thought it was like 3 of them.
Oh no. A 3-digit number is like 100. So
yeah, I know that now.
Okay, cool.
I believe number 2. I'm not actually sure, so I'm just gonna.
Okay, it's into. Okay, Edward, I'm gonna go meet you a little bit. Okay, is that fine? Okay.
I need to ask my dad because I'm not actually with because I'm at my other grandpa's house, so my computer isn't here with me.
No. I'm just gonna meet you for a second. If you need to ask me a question, you can always unmute and then you can unmute.
You want to see? Do you want to like know my? Are you trying to know what my Gmail is?
No. You know what? Never mind. Okay. By the way, check question 2 again, Edward. Remember we're doing the alternating pattern. I'll show you guys.
The alternating.
Yes.
I'm actually not exactly sure about the alternating.
Okay, sure.
It's a bit confusing, and I tried doing it, and it doesn't really work that way currently.
I'll just go over question 2 right now.
Wait, it's actually T. It's actually right. I kind of forgot another step in it. I forgot to add I believe it's add the 11 to the first 2. No, the 3
for the first. Here. Let me show you.
Yeah, 11. I know. I'm gonna just annotate and show you.
Yeah. I'm just gonna go annotate and then basically what you do is you. Oh wait. Okay.
Wait, no, you can do it. No, never mind. You can do it.
Yeah. Okay.
Okay.
Plus 9. So you see what I'm doing here? Taking the first digit minus plus.
1 minus.
Plus. So it changes basically.
Plus 5 minus 3 plus 9. Yeah. Oh my God! What is it?
So 1 minus 1 is what?
0, and 5 minus 3 is 2.
So 2 plus.
2 plus 9, that's 11, and that is 11, so that's 11.
Yeah, so this is divisible by 11, so number 2 is true. Okay, you got that? Cool. Did you get question 3?
Question 3, I'm currently doing it, and
okay.
I can see that. I know that 64 is divisible by 8, but
okay, so
1064 is no.
No, you sure?
1064. Okay. Wait, no. Wait, no. Wait, is it 1 minus 0 plus 6 plus minus 4? I'm confused now.
Okay, so basically what we do to check if it's divisible by 8 is that we first check the last 2 digits and see if it's divisible by 8. And if it is, then that means that this whole thing is also divisible by 8.
Yes, but I see it, but it doesn't seem like it because 8 can't make something like 10 or something. 8 cannot be made with 10.
I mean, Ian. Okay, yeah.
It's Ian.
Oh, Ian? Okay.
No, it's Ian.
Okay.
Oh,
Okay.
it's Ian.
Yeah. I don't know if
Accidentally
you fix
pressed
this,
wrong.
but just don't edit anything, please. Thank you.
Accidentally pressed wrong.
Okay. I don't know how to change that, but it's fine. Just don't edit in, you guys, okay? So what we do to check
Okay.
if the number is divisible by 8 is first we check the 2 digits, and then we basically see if like 64, that's divisible by 8, right? Because what's 8 times 8?
8 times 8 is 64.
Yes. So this is divisible by 8. So therefore 1064 is also divisible by 8. Okay?
1064. That's a completely weird question because
Yeah, all we're doing is it's just a method for us to see if this whole integer is divisible by a number.
I don't understand this
I know
method.
it's a little confusing, but think about it. Ian, can you not do that? Thank you. Think about
Excuse me.
yes.
Like for the second question, like what does it mean?
The second question
Yeah.
is sorry. Yeah, I was trying to explain something. Let me erase this then. So is 11,539 divisible by 11. That's all I'm asking. Can you divide that by 11? And I kind of already showed you what I did over here as well on the right hand side.
Yeah. But how is it 80? Like, if it's 1,000 cannot be divided by 8, and
try it.
80 is confusing.
Well, try it. Is 1,000 divisible by 8? Go try it out.
1,000 is. Okay. It's like so confusing. Okay, I'm just gonna do some simple. Okay, 40 and
yes. Okay. So
10, so
yeah.
80. That's like.
Let us skip this, and if you have any questions, we can go after class. Okay. Does that sound good?
Okay, I'm actually.
Okay, I'm gonna go mute you now. Okay. Okay. Now let's go to the next slide. I don't think there's any questions. If you guys have any questions, you can always talk to me before class. So okay, let's move on. Announcements. Today we'll be taking quiz 2 and 3 combined. And again, if you need notes or are not receiving any emails from me or Eric, please reach out to me at this email, kinderturtle@gmail.com. Okay, sounds good? Cool. Okay. Eric, can you put the link of the quiz in the chat, please? Okay. And then we'll get started then. Once you put the link in, I'll press the timer, and you guys have 10 minutes. Okay, good luck.
Excuse me.
Yeah.
I didn't get the second question. Like, why does to see that if the if the number is can be is divisible by 11, how does it work?
That's a good question. If you want, I can explain to you after class. Does that sound good?
Okay.
Okay, cool.
Could you please stop the timer for a second? I cannot open the link.
Oh, okay. Sure. I mean, the timeline is not really too big of a deal. I just want you guys to finish on time so you can get onto the lesson today. Okay. Here, I think Eric can help you with that. Okay, I'm just gonna start it again. And I think Eric, you should also send in the non-condensed link. Yeah, there you go. Now try that.
Mr. Kyle?
Yeah.
You never actually taught the distributive and associative.
Yeah. I know. Just try your best. And these quizzes are just to basically see where the whole class is basically. That's all.
What is?
Okay.
I don't. What? Oh my god, this is so confusing to me.
Well, what does that mean? That's just a power symbol?
Yes, that is a power symbol. That is a caret. Mhm.
Mr. Kyle. Mr. Kyle. Mr.
Sorry,
Kyle.
yes. Sorry, I was muted.
How am I supposed to get the questions correct if I don't even know what the questions are that are right?
What do you mean by that? If you don't know the questions, just try your best. I won't hold you accountable. Since you weren't here.
Yeah, because I have seriously no idea whatsoever what to write. I just know that, oh, parentheses, blah, blah, and all that. I know that 264 and yeah.
Okay. You can talk to me after class.
Okay.
Teacher? I think
Oh,
there's something. I think there's something wrong with one question.
yeah. I realized that.
What are the multiples of 2y, 0, 1, 2, 3, and 4?
Yeah. It's just 1 and 2. Yeah, I accidentally clicked on the wrong one. It's 1 and 2. You're right.
You gotta be kidding me.
You're good. So for like the multiple 2 question, it's 1 and 2. And
how about what are the multiples of 24?
Yeah, that's all other question, and it's the 1, 2, 4, 6, 12, and 24. That's the answer for that one as well.
I think
Yes. Yeah.
I think you accidentally clicked wrong again.
Yeah. Sorry about that. I'll check to make sure that we fix these next time.
Yeah. I'm just gonna wait.
Yep. Let me see. I think it should be fixed now. You guys can go back and check the score again.
Oh, never mind.
Okay, and then I think that is time. Okay. So let me go back and present. Let's go back to lesson. Okay. Cool. Can you guys see this?
Yeah.
Okay, cool. Let's move on with the lesson. Sorry about the quiz, guys. Okay, so today we'll be going over basically prime numbers, least common multiple, and greatest common factor. So let's start with what is a prime number? A prime number is a number with only 2 factors, which is the number itself and 1. So for example, 2 is a prime number because the 2 factors are that it can be divisible by 2 and divisible by 1. Okay?
Yeah, prime number.
So that is a prime number. So let's just do a quick exercise. So let's start with 1. Is 5 a prime number? You guys can type in Y for yes and N for no.
Okay, so okay. I could open chat for some reason. Oh
yes.
I could open chat. Why can I open?
Okay, anyone else? You put Y for yes and for no. For number 1, is 5 a prime number?
Mr. Kyle?
Yes?
Are like prime numbers the one that are like only able to be what's it called again? Only able to be divided by 1.
Yes, that is correct.
Yes.
Or itself. So like 5 is divided by 5 is 1. Okay, cool. So let's go on to the second one. All you guys got that correct. So what about 39? Is that prime?
I am not finished.
Not finished with what? Okay.
This.
Okay. Here, I'll give you some more time then. Okay. Okay. Good. Ian, are you done? You good, Edwin? Yeah. No? Okay. I'll give you a few more minutes then. Okay, seems like most of you guys are done. Okay, so for 2, type yes if you think it's a prime number and no if you don't think so.
Oh, I already picked the answer.
Oh no, okay. Well, can you guys load in the answers into chat so you guys can all answer at the same time? I didn't get to respond to most of you, so let's see what you guys.
Doesn't 1 only have itself as a factor?
Just load in the answers and I'll count you guys down from 3, 2, 1. And you guys can press enter at the same time, okay? So for 2, Y for yes, N for no. 3, 2, 1, press enter.
Doesn't 1 only have 1 as a factor?
Yeah, 1 only has 1 as a factor, so it is a prime number. 5 is a prime number. We're going on 2 right now.
No. I'm talking about 1.
Yeah, 1 is a prime number.
Prime?
Oh, sorry. I talked to you about question 5. Sorry. Question 5. Yeah.
Question 5, yeah.
Yeah. Okay. So yeah. 39 is not a prime number because it can be divisible by 3. What about 21?
21 though.
Yes or no? 3, 2, 1. Press enter. No. Okay. Yeah. It's also divisible by 3. Okay. And then 10 again. What is divisible by? Anyone can type in the answer. Yes, 2. So therefore it's not prime. What about 1? Is that prime? Okay, so think about the definition.
I just typed wrong on number 2.
Okay.
Typed wrong on number 2.
Is 1 prime or not? 3, 2, 1, press enter. Technically, it is no, because what prime numbers are is that they can be divisible by its identity and 1. So technically, it can be divisible by 2 things. But for the number 1,
it can only divisible by 1 because times
but it's only divisible by 1 number. Technically, for prime numbers, it's divisible by 2 numbers. So for like, say, the next question, 17, it's divisible by 17 and 1. So therefore, technically, that's why people say 1 is not a prime number, but 2 is. So that's what I was trying to get. So 1, just remember, is not a prime number.
And on number 2, I think I might have just pressed wrong. I mean, type wrong because I think it's no for number 2.
That's fine. That's fine. As long as you know what the right answer is, you're good. Okay, let's go on to the next slide. And now we're going to go back to the factor tree. You guys remember this from yesterday? It's where we divide the numbers into its most simple components or its prime numbers. And we draw a graph like this tree you see on the top right. Just kidding. It's on the left. And we determine for the multiples of number, we divide the numbers into prime factors basically. So for example, on 12 on the left, we see that it's divided into 3, 2, and 2. So the prime factors of 12 is 2, 2, and 3. Does that make sense? Okay, cool. So let us practice a few of these questions. So I'll give you guys 5 minutes and you guys can give me the prime factors of these 5 numbers, okay? Does that sound good? Okay. And you guys can
Mr. Kyle.
Yes.
Like, how do you suggest us to break down 24 into prime numbers?
Just separate it into anything. So you can separate it by dividing it by 2, dividing it by 4, just any way that you'll get whole numbers.
So can I just say like 24 breaks down into like 1, 2, 3?
No. I want you to have you break them down into prime numbers.
Yeah, so prime numbers. 1, 2, 3. Play me random stuff.
Here, let me give you an example. For like 24, this is not multiples. This is prime numbers. I want you to break them down into prime numbers. So for 24, you can break them down into say 12, 2. You can break that down into 2, 6, and then 3, 2. And then what you'll get is the prime factors of 3, 2, 2, and 2 for 24.
Yes, but like 2 still can be like made into 1 end.
No. I just want you to.
Oh, right. Yeah, I forgot.
Write these numbers here into a list. That's all I want you to do.
Yeah, okay. Yeah, I kind of got confused.
Okay.
Oh, fun fact. Did you know 2 is the only even prime number?
Yes. Yep. Okay. So you do know that. Cool. Okay. Let me put back on the timer and I guess I already did 1. So we save this and start. Okay, and you guys always can send answers to Eric as well. You don't have to send it to me. Okay.
Mr. Kyle?
Yes.
For number 4, can't you like do like 100 and turn? It's not just 50 and 2. There can be like different multiples, and you'll get
so
like
you see
different.
What I did with 24.
You could get different, but you'll still get different answers.
Not really. If you divide it into its prime factors, you always get the same list because you're dividing it into its most basic components. So you see from 24, I divided it by 2 and I got 12 and 2. I got 2 as one of the prime factors and I did that again, got another 2. I did it by 6, I got another 2 and a 3. So no matter how you divide it, here, let me draw this out for you. Even if I do like 24 and 6 and 4, because 24 divided by 6 is 4, we also get 2, 2, and then 3, 2. So in the end, we always get the same list. Does that make sense?
Yes.
Okay, cool. Okay. Seems like most of you guys are done. I'll give you guys another minute.
Dun, 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 dun.
Okay, sorry. Um, so since we're done, let's do like the question 2. Can you guys learn the answer to question 2 in chat? Okay. 3, 2, 1, press enter. Okay. Okay, good. Yep. It's just 5, 5, and 2 because we first divide, say 50 by 2, you get 25, and then 25 just 5 times 5. So in the end, we get as prime factors is 5, 5, 2. Okay. And then 16, same thing. It's 2.
Mr. Kyle.
Yeah.
I kind of sent you all of my answers in the chat already.
Okay. Cool. Yeah. Yep. You're good. Yeah. Yep. It's all correct. Okay. And then let me just quickly go over 4 and 5 then. So for 100, we can divide that by 2, you get 50, and then 50 raised to 2, 5, 5. So we can add those factors on as well. And then the last part, it is, I believe 196. I can't really see. Give me a second. I need to readjust this. Yes, 296. And then now we can divide that by 7. And then afterwards, once we divide by 7, we get 28. And then we get 4, 7. So we get 2, 2, 7, 7. Okay, good. Most of you guys got that. Okay, cool. So let's move on to the next one then. Okay. So next slide, we're going to be talking about why we need to learn factor tree. Factor tree allows us to basically solve LCM or least common multiple as well as GCF. So the least common multiple is trying to find the smallest multiple between two numbers. So for example, the smallest multiple between 6 and 8 is 24, while the smallest share factor between 2 and between the two is the number 24. Does that make sense? So say like you have hot dog buns that were sold in packs of 6, and you had hot dogs that were sold in packs of 8. What you want to do is to not waste any hot dogs is find the least common multiple so you guys know how many hot dogs and hot dog buns to buy, basically. So you don't waste any. Okay? Cool. Let's go on to the next slide then. So this just shows you how to do it. We solve the least common multiple of the two numbers by first drawing the factor tree, which you guys did already. You guys did great. And then we compare what prime factors are missing between them. So can anyone tell me what prime factors are missing between 12 and 38? You guys can type in chat, or you can message me directly, or unmute yourself. So what prime fact? Let's say what 3 prime factors are missing are different between 12 and 38. Wait, not exactly. 2 is not the least common multiple, actually. The least common multiple is basically the number that is divisible by both of the two numbers that you're trying to find the least common multiple. What you're trying to do is find how can you make it so that 12 and 38 are mixed together and can be both divisible by one number.
This one is very easy. Unless you count fractions.
Wait, Ian, so what is your answer then? What prime factors are missing between 12 and 38?
Prime? Oh,
Yeah,
prime factors. Got it.
So like the 3, the 2 for 12 are its prime factors, and then 19 and 2 are the prime factors of 38. So what 3 prime factors are different from each other?
Got it.
You can talk to me out loud as well.
Do you mean the least common prime factor?
Like what 3 prime factors are different from 12 and 38?
What?
Like
3?
Yeah. So how is these numbers different from this number? What 3 numbers are different between these two? So say
3
like
numbers.
Okay, here. So do you see this 3 here? Do you see a 3 on 38?
Yeah.
38? Well,
Oh.
the prime factors itself. Do you see a 3 here?
Yeah.
Wait, so this and this. Is there a 3 here? There's a 3 between the 19 and 2?
No.
No?
I have no idea what you're talking
No. Yeah. So this is unique. We don't see 3 in this prime factorization, basically.
Yeah.
So what about 2 2s? There's 2
Yes.
2s. Do you see 2 2s here? How many 2s do we see?
No.
So how many 2s do we see?
1.
1. So this 2 right here, this one right here is unique as well. And then what about 19? Do you see a 19 in the 12 anywhere? Is it? Is it? You see the 3? You see
No.
the 2? So yeah, no. So this is where we go on to the next slide. So we see that in 38, we're missing the prime factors of 2 and 3, and in 12, we're missing the prime factors of 19. So what we do to find the least common multiple using these factor trees is first take the prime number of 2 and put it in this equation right here. So there's 2. And then afterwards, we take the unique prime numbers that was not present in both numbers and we put it into this equation. We add it into this string of multiplying, okay? And then this is what we get. This is our least common multiple. You guys get that?
Got it.
Okay, cool. Then let's do some.
No, I didn't get it.
Oh, you didn't get it? Okay. Well, we have another example right here. So let's do 16 and 20. So you see the prime factor trees, right? So for 16, we get 2 times 2 times 2 times 2, like what we did with the previous question. And then for 20, you get 5, 2, and 2. So what is different between the prime factors of 16 and the prime factors of 20? Lori?
Well, the prime factors of 16, there is a unique thing, like the unique number, like it's the other 2 and 2. And for the 20, it's like the unique number, it's 5.
Yes. So you see that in 16, we're missing 5. And then for 20, we're missing the prime factors 2 and 2. So what we do is that we take the common factors of these 2 and these 2, and then we put into our string first. And then afterwards, we take the unique ones that was not present in both of the numbers, the unique prime factors, and then we put it into the string of multiplying where we get our least common multiple. Okay? And then a good,
Yeah.
huh? Can you say that again?
I said I got it.
Okay, cool. And again, to make sure that you got the least common multiple, you have to first check if it's divisible by 16. And you guys can usually see that 80 divided by 16, and it's divisible. And it'll equal up to 5. And then you can also see that 80 divided by 20 is also divisible, which is 4. So this is an easy way to check if the number that you got is the least common multiple. Okay. Any questions? Okay, let's move on and let's do some practice then. So here are some 4 questions, and then all we're going to do is just find the least common multiple between numbers. No, just numbers. Finding the least common multiple between the 2 numbers.
Least common multiple?
Yes. Okay. I'll give you guys. If you have any questions, you can text Eric or text me. Cool.
Oh, Mr. Kyle. Mr. Kyle?
Yes.
My mic keeps on kind of getting, well, no, my speaker that's transcending into the headphone is kind of getting scratchy.
Scratchy? Okay.
Like it's not like, it just doesn't work too well. I couldn't really hear you very well.
Okay. So I can't really help you with that. We can talk to you. I can talk to you after class and see if I can fix that somehow. But that's
but like I couldn't hear what the least common multiple.
Oh, okay. Did you see the slides though?
I'm trying to open captions, but I do not know how to open it.
Okay.
I was trying to open it the whole time, and
yeah. Just wait.
I'll go. Wait, let me plug and
okay.
Okay, done.
Okay. Does that sound better?
Yeah, a lot better.
Cool. What I'll do, I'll just explain the first few questions, and then based on that, if you still have if you don't understand anything, you can ask me and I'll go back to the slides. Okay?
Can't you just kind of like send me the slides in the chat and I can kind of see it?
That's such a good idea. Yeah. Hey Eric, can you send him the slides in chat?
What?
Excuse me?
Yeah.
Can you let the other kids mute because it's like a bit annoying.
Okay, sure, yeah. Okay. I'll mute both. Okay. Thank you for telling me. Okay, time's up.
Mr. Kyle.
Yeah.
Well, it's like the total number in the end of the thing of the contraption. I'm confused.
Okay, you can talk to me after class, is that fine?
Sure.
Okay, cool. Let's go over the first question then. Well, let me just do this out. You guys don't have to answer anything. Let me just do this out. So let's first draw the factor trees, these numbers. So we get 8, so it's 2, 2, 2, and 2, 2. So we first take the common ones, which is 2 and 2, and then we take the uncommon one, which is 2. And what we get is that the least common multiple is 8. Okay? Yep, and most of you guys got that. So then for the next one, let me clear all this. We have 12, 18. We first split these two, we get 3, 6, 2, 3, 2, 3. And what I can do is I already see that there is a 6 here. So I can use that first instead of having to go back to prime, because I know that 6 is the prime of 2 and 3. It has prime factors of 2 and 3. So now I take the 6 times 2 times 3, which is 36. And this is the least common multiple of 12 and 18. You guys got that? Okay, so now let's go on to the next question. And then for this one, it's a little more difficult, but it's the same concept. We do these factor trees again. 2, 3, 3, oh, well, 9, 11, and you can separate that into 3 and 3. You fix that a little bit. And we can see that the 3's are common. So I'll take the 3 times 2 times 3 here, and then times 11. And then in the end, I believe, let me check this. So we got 6 times 3. You get 18 times 11. And then with 18 times 11, you get 198 for question number 3. Okay, and then for the fourth question, it's actually really simple because we see that first 13 is a prime factor and 7 is a prime number as well. So what we do if both numbers are prime is that since they don't share any common multiples of like 2 or 3, we just times them together. So all we do is just we do 13 times 7. This is 1, 2, oh, and then we get 91. So that's the final answer. So kind of cool thing is that if you have prime numbers, when you're trying to find a least common multiple, you just multiply them together. Okay, cool. Does anyone have any questions? No? Okay, let's go on to the next slide then. Okay, and now we're going to be talking about the greatest common factor. So the least common multiple is kind of like the opposite of the greatest common factor. So instead of finding like the biggest number that's shared between the two numbers, we're trying to find the factor that's shared between the two numbers. So think about like the common factor that we saw between like, let's say these two numbers, 12 and 28. So can anyone tell me what two numbers are the same between these two? Here, Nicholas, can you speak? Can you unmute?
What?
What are the two common prime factors between 12 and 28? I drew out the factoring tree here. So can you tell me which two are the same?
I think is 2 one of them?
Yeah, 2 is one of them. Yeah, it's actually both 2. Yeah, so you see that we have 2 here, there's another 2 here, and then 2 here, and then 2 here. So the two 2's match. So in this case, the greatest common factor between 12 and 28 is 4. And you can check this as well. So 20 divided by 4 is 7, and 12 divided by 4 is 3. So these are the greatest common factor. Okay, you guys got that?
Yeah.
Cool. Let's go on to the next slide then. This is very simple as well. We'll just be doing the same numbers again, but with trying to find the GCF now. So same thing as what we did with LCM, we're going to do with GCF. Okay, cool. Okay, and then once you guys are done, you can send the answer to Eric and he can check you guys off and you guys can leave. Okay, sound good?
Okay.
Cool.
But am I supposed to like stay to like understand what least common multiple?
It's up to you. If you want me to explain things, I'm always free and you guys can stay after class and I can explain things more. But you don't have to stay.
Okay. But I want to know what it means.
Yeah, sure. I'm glad to help you. Yeah. Feel free to ask me anything after class.
Wait, Mr. Kyle.
Yes.
Isn't like class supposed to end currently?
Yeah, that's why I'm saying once you're done, you can leave. But if you have like questions, you can stay after class.
I see a video that's like after the again but with GFCF.
Yeah, I stopped that because class is almost over. So once you guys are done, you can leave.
And Mr. Kyle, your greatest common factor is kind of confusing for me.
Yeah, I'll go explain things in 3 minutes. Oh, sorry, and let's say 1 minute, and then you guys can leave class after that. Sound good?
Okay.
Yeah, just keep trying, okay? Just try and find a number that can be divided by both. That's what greatest common factor is basically all about. Try and find the biggest number that can be divided by both. Yeah, bye now.
Can I leave?
Did Eric check you off, or did you finish the questions? Okay. Yeah, sure.
What?
Okay. So let me go through this quickly. You guys can leave. So for 8 and 4, we have 4, 2, and we have 4. You see that 4 is common between both of them, so the GCF of 1 is 4. Now for the second one, we have 12 and 8. We first do this, and then back to tree again very quickly. I see that 6 is common, so the greatest common factor of 2 is 6. Now let's do the third one. And again, we get 2, 3, and we get 9, 3, 3, we get 11. And we see that 3 is common, so the greatest common factor of between 6 and 99 is 3. And then finally, because these two are prime numbers, there's only one factor. And you guys know what that is? What do you know?
No, I'm kind of doing 1, 2, and I was kind of doing 1, 2, and 3, and that was the last question that I was doing.
Think about the definition of prime numbers. What are the definitions?
Not exactly. Something like that, yes.
You know?
What?
What are the two? What are prime numbers?
I don't know.
Okay, it's 1. Okay, got that? Okay, cool. You guys can leave now. Okay, I'll see you next week then.
I guess bye then. Bye.
Bye.
Bye. Wait.
Oh, okay.
Excuse me?
Yeah?
Can you explain the 11 rule for me now?
Which rule? Sorry. Can you say that again?
I said, can you explain the 11 rule? How does it work and why does it work?
Okay. Here. Let me stop the share.